But yeah, no, thank you for everyone that's came. I want to walk you through our migration from EC2 to Kubernetes. I know my format's a bit off here, but hopefully you can still make that out. And you know, why the Azure track? We migrated our cloud platform from EC2 into Azure, and I'm going to talk about a couple of reasons why we chose Azure over AWS. Okay. Hands up, has anyone actually done a migration from virtual machines to Kubernetes or containers? Anybody thinking about doing one? No? Okay. That was a good start.
Convince me.
Don't do it.
Thank you.
We did do the migration, but basically it was the application which were running into the virtual machine in data center, and we migrated it to OpenShift.
Okay. Yeah.
It was for the client.
Okay. So you
One landing client.
Yeah.
So we did do that.
and you'll know it's not an easy job, and I'm going to kind of talk through that now.
Yeah, for sure.
And why haven't I kind of mentioned brownfield migration as well? Essentially, a brownfield migration is taking your existing set of applications and migrating that into a container, so and keeping all the existing configuration, whereas as opposed to a greenfield, totally rewriting your application from scratch. So yeah. So a little bit about me. Based in a town called Pontefract. I'm not sure if anyone's heard of that. Normally when I do these things, nobody's ever heard of Pontefract. But I've been at Octopus since 2019. So I joined as we just started building our first public cloud. There was around 30 of us then when I joined, and we're about 300 now. So yeah, I'm in the sales team now. I've worn many hats. I promise you I'm not going to try and sell you Octopus today. But yeah. So I want to walk you through how we originally built our Cloud V1 product and had hundreds of Octopus Deploy customers hosted on EC2 machines, and how we managed to migrate to a Cloud V2 platform that has thousands of customers running inside Kubernetes, and also some of the challenges around that. I want to share a few lessons of things we learned during that process. That's not great. I'll describe that. So Octopus has four key components. There's the Octopus server deploy application, which is a container image. We also have a relational SQL server, and then file storage. We also have components for networking and load balancing, not only to access the UI, but we also have agents that connect up into Octopus as well, that need different kind of load balancing services. So let me first start with talking to you about our Cloud V1 and our rationale behind actually hosting it on EC2 machines. We first released Octopus back in 2012, and we provided an MSI file for people to install Octopus. Very simple, take the MSI, .NET framework, install it on a machine. If you wanted HA, you'd install it on multiple nodes, okay? It was relatively simple. By mid-2017, we had thousands of customers at this point. It was all kind of bought off the shelf. It did really well, but we had people constantly asking for a cloud offering, because people just didn't want to maintain Octopus, okay? But we couldn't quite gauge the demand for that. Yes, we had hundreds of customers asking for it, but we had thousands of people that had downloaded the software and were running it. So we kind of chose a path of least resistance. This is going to be very technical. We took the MSI and we installed it on an EC2 machine, and that was our Cloud V1. Okay, and it went very well. We had hundreds of people that signed up for the cloud offering. So yeah, we released it in July 2018, and we had hundreds of people that signed up for it. Now, in August 2018, a month later, we got our first AWS bill. And honestly, between trials and people wanting to migrate, it did really well, probably too well. And you probably don't want to know what the kind of price of that first bill was. I still don't know, but I know it could pay off my mortgage. And why that's important is because we were kind of bootstrapped at the time. So the only money we had was the profit we made from actually selling the product. So we didn't have millions to invest in a cloud platform. So, but yeah, it went well. That demand comes at a cost. Okay, we decided, okay, there is appetite for a cloud platform. We need to rebuild. Okay, Well, this does bring me on to my first lesson. Cost shouldn't be the sole deciding factor when moving to Kubernetes, okay? There's got to be other reasons for you to make improvements to your own application, because there's going to be costs from managing Kubernetes anyway added on. So there's got to be other reasons for you to do that migration. You can't just be cost alone. Now, it was our biggest driver, okay? And it gave us our drive to make the improvements. So the way we needed to reduce costs was increasing the customer density on the resources we were already consuming. We kind of tracked all the metrics of the cloud instances, and many of the customers were using less than 20% of each virtual machine that we gave them. Some did use 95%. Nobody ever used 100% of the resources, but we actually didn't know when they would need to use those resources. It was really hard to increment the VMs, which I'm guessing most of you know. We had multiple tiers in AWS, so 2 CPUs, 4 gigs of RAM. The next tier, 4 CPUs, 8 gigs of RAM. If we want just to increase a customer slightly to, let's say, 3 CPUs and 5 gigs of RAM, we'd have to move to the next tier, which essentially would just double our hosting costs. So we knew we weren't going to keep the same model. So while we were deciding on Kubernetes, it wasn't our first choice, okay? Initially, what we were going to do is run multiple Octopus services on a virtual machine and try to maximize the compute resources on that virtual machine. The other option from AWS was to run a serverless product. Now, the problems with those two things, VMs still weren't going to scale, and serverless would not only require us to rebuild our cloud platform, but also our server products as well. So we'd have to change all our on-premise customers to this new architecture just for us to rebuild cloud. So we decided on Kubernetes, and the reason for that was Kubernetes allowed us to increase customer resources per instance and more granularly than what we could do on a virtual machine. It scaled much better than the virtual machines, and it also kind of gave us desired state and kind of auto healing features that we've been trying to work on in virtual machines, but it was just out of the box with Kubernetes. One of the plus sides for us, Octopus Deploy does deploy to Kubernetes, and our customers use Octopus Deploy to deploy Kubernetes. We just released an integration to do Kubernetes in 2018. So we thought, okay, well, this is a good chance for us to actually dog food our own Octopus Deploy integration by deploying Octopus Deploy in Kubernetes. Okay, so that's kind of a win-win for us on that side. So I'm going to talk about some of the things we had to do before we could even host Octopus in Kubernetes. We had to kick off a container migration because up until this point, we had only ever built Windows containers, okay? And we had to decide, were we going to self-manage a Kubernetes cluster or pick up one of the cloud offerings? And again, the reason why we would have had to build our own is because we only had a Windows container. The cloud providers didn't support Windows containers, and they wouldn't for at least another year. Obviously with that, those AWS bills constantly ticking up, we didn't have time to wait. So we decided to port over to Linux. Linux has many benefits. One, it consumes fewer compute resources, and just the kind of big one, the actual Windows container image, it was just short of 7 gig for our server product, but Linux was just over half a gig. Honestly, I still don't know why that Windows container is so big. It kind of defeats the purpose of the object of having the container.
There are internal dependencies as well.
Yeah.
For the operating system.
Exactly, and
It's not good.
it doesn't scale, and that's why we kind of ported over to Linux. But so that's another consideration you're going to have to make, okay? And this brings me to lesson 2. If you're going to do this type of migration, expect it to last a lot longer than you actually planned for. If you think it's going to take a year to do this migration, it's going to be 3 years. You know, unless you've got tons of money to throw at this thing.
I think that's what Auto Trader were saying in
Right, yeah.
Keynote as well.
Exactly. I think we had a chat with him earlier. It was the same kind of response. And we had a pretty good plan for getting a product ready for cloud, but it took us a lot longer to get the container ready for our on-prem customers. It was no trivial task moving to Linux. Okay, we were on .NET. We were using .NET Framework. So first we had to port from .NET Framework to .NET Core. That isn't easy, okay? Like many applications, we had third-party libraries scattered throughout our product. We had to vet and make sure they were going to work on .NET Core as well. If not, find another library or rewrite something that works for us. We also reference the Windows registry quite a lot, and you know, we had to find a solution that works for the the cloud instance, and also the on-prem instance as well. So finding ways to remove the dependencies on Windows, like the registry, was a big task for us to do. We also had to ensure all the file system interactions worked. Octopus, when you deploy, there's lots of log files that get generated in the UI. We hammer the file storage, so we had to make sure that was kind of bulletproof, because these logs are used by banks for their auditing, so it was critical that was right. And then finally, we had to find and fix all the bugs in our own code from migrating to a different framework. One of the toughest challenges, and it's kind of talking about the post-migration, we used HTTP SYS for authentication when we were using .NET Framework and on Windows. We moved over to Kestrel, and that caused lots of problems for our on-premise customers. So what we ended up having to do is support two types of authentication in the products. We had HTTP SYS and Kestrel, and then we had customers who wanted to self-host this container on Linux, so we had to add LDAP support in there as well, and we had to just continue fallout from those issues. One of the biggest things we had to deal with as well was the Microsoft SQL client. So using the Microsoft SQL client in anger on the Linux container, we had lots of issues. We even had Microsoft come see us and work out some of these big problems that we had with it. So that's kind of the where the pain is. And the biggest issue for us, you know, we are kind of self-funded, we're bootstrapped, we haven't got all this money to buy new dev teams. We still had this existing customer base that were doing mission-critical deployments around the world. You know, we needed to debug fix still, we needed to security patch, we needed to do feature work. When customers asked us for a new feature or a bug fixing, we couldn't turn around and say, we're migrating to Linux, give us a year and it'll be solved. We had to kind of build a plane while we're still, while we're flying it. And that was a really tough time as well, by the way. I want to highlight that because you have all these feature requests. The DevOps industry moves so quick. You need these changes. And we didn't have the resources to put into it. So we're going to talk about lesson 3. So we're migrating to Kubernetes. Kubernetes and containers don't make sense for all use cases. And as I mentioned, we have SQL service, file storage, and network and load balancing stuff. Now, we did think about, hey, let's run our own containers for SQL Server and run our own containers for file storage. Yeah, we quickly ruled that out. We'd have to become DBAs, we'd have to become file storage admins, we'd have to monitor the uptime and all the resources, and then alert on these things. We could have done it. Obviously, we're a tech company and probably people that wanted to do it, but just because you should doesn't mean you should, okay? And we decided to leverage the cloud for the managed services. So Azure, we leveraged the AKS, SQL service, and file storage. And the reason why, it's their expertise. You know, they're focused on this day in, day out, and these services are set up for production scale automatically. There are features that they've got in there that would take us a long time to build. So, for example, you know, zonal and geo-redundant backups, just out of the box. You know, trying to build that yourself, as we all probably know now. This was 5 years ago. You just don't want to do it yourself. Interestingly, it kind of brings me to lesson 4. Not all managed services are are the same, okay? So when you think about, okay, I'm gonna host my SQL service in AWS, I'm gonna host it in Azure, does it really matter? It actually does, and something that kind of we learn. One of the challenges we've had with AWS, how Octopus was gonna work in the cloud, there's gonna be a database server that the cloud provider provided, but we want every customer gets their own database. We wanted to host as many databases on that service as possible before moving to another database server that was going to cost us money. There's actually a limit on the number of databases that AWS provided, and there's also a limit on how elastic that database service could be. So that's why we chose Azure, because it suited our business needs better. I don't know if there was a limit on Azure, but it was certainly a lot larger than what it was on AWS. So for the next lesson, I want to provide a bit of context around Octopus Cloud so you can understand some of the challenges that we faced and we continue to face today. And I'm on 5-minute warning here. We've got 1,900 customers, customer instances hosted across 3 regions in US, Europe, and Australia. We have 8 Kubernetes clusters. We leverage virtual machine scale sets. Each one typically has 3 to 6 nodes. And we use the E20s that have all got 20 CPUs and 160 gigs of RAM. And we could host typically between 300 to 500 instances on those clusters, all depending on who the customer is, okay? Each customer gets their own dedicated container and namespace in the cluster, a dedicated Azure SQL database, Azure file share, and something that we call dynamic workers on demand. So let's talk a little bit about managing these thousands of customers at scale in Kubernetes. This brings me to my lesson 5. The operations work around managing these clusters and these cloud users shouldn't be a part-time focus. You have to have a dedicated team to manage this. Okay, it should be hey, Tony from Dev will take care of this. It's got to be a team that handles this. And that's because we've got 1,900 customer instances. What's interesting, if we did stick to the VMs, we'd have 1,900 virtual machines. That would just, you can imagine the price of that and the management of it. And in addition to the kind of 1,900 customers, we've got a variety of different use cases. So we've got some customers that deploy a couple of times a day. Typically, we've got customers that deploy 100 to 200 times a day. And on the extreme end, we have customers that deploy thousands of times a day around the globe. So we've got big enterprise orgs that are trying to scale Octopus to do these 1,000 deployments a day. And we wanted to increase customer density on the existing resources we were already consuming. But we needed something that a team that could deploy to these instances at scale. It could somebody could prevent noisy neighbours from one instance to another, and also monitor all the instances and alert us. So that team was going to be responsible for that. And it brings me to another lesson, that custom tooling for specific business requirements is preferred over misusing a tool, okay? And I'm going to talk about the custom tooling that we built for our cloud product. We built a cloud portal, and it's a custom built tool, and it's responsible for telling Octopus Deploy to deploy Octopus Deploy. It interacts with all our third-party tools to provide all logs and alerts and service them into one dashboard. It's also responsible for triggering many of the common day 2 maintenance tasks. So if you think about deployments, day 1, you get the software out there, and there's also all sorts of maintenance tasks. Can you back up? Can you defrag a SQL database? Those kind of tasks. We do those maintenance tasks through the cloud portal, and the cloud portal gives the customer a chance to specify their own maintenance window. Okay, so we have a 2-hour downtime period every night. We don't always use it, but the customer gives us a time, 2 a.m., 4 a.m., you can do the maintenance work, and the cloud portal will automatically run all these tasks and do the deployments, like snapshots, upgrades, increasing, decreasing compute resources. The cloud portal is responsible for that. Also prevents what we call kind of guard clauses to prevent unnecessary work. So For example, we have maintenance tasks that do a defrag on the SQL database or SQL work. Does that SQL database that customer need it? No, we can measure that and say, okay, don't run that task pointlessly and bring their instance down, and that's all from our custom tooling that we've built. The cloud platform team and tool enables to do these day two operations at scale. These are some screenshots of my colleague's instance a while back. All these task IDs here, these are all the deployments that happen in a week. So we're patching the cloud every single night, whether it's a new feature or a new security patch. And it's actually hard to keep up with them. I'll be doing a demo and there's a new feature, I'll just be like, oh, we've added that now. And on the right hand side, you can see all the maintenance tasks down there. So you can see, we're provisioning new instances, we're moving compute about. So yeah, that's what that's responsible for. And the simple truth is, this is all custom software. Okay, it is leveraging a little bit of Octopus Deploy as well, but there was no tool out there that could have done this. We had to write this ourselves. Okay. The team, the portal, is also responsible for stopping the noisy neighbours. Okay, how we do that? Every instance starts off with a baseline set of resources in the Kubernetes instance. Kubernetes is great for that. That you can say, hey, these get 1 gig of RAM, 0.25 CPU. We then leverage Azure CLI and the AKS CLI to then work out, okay, based on who this customer is, their usage pattern, it will automatically then upgrade the usage of the customer or decrease it. But the baseline set of resources are kind of based on our historical data from on-prem and the cloud products. But that's how we prevent noisy neighbors. Everyone gets their own instance, and then we are constantly adjusting the compute resources up or down based on their usage. Another challenge we had was upgrading the clusters. We've got 8 clusters with all these instances running on. How we kind of combat this is we spin up a new cluster. We then use a cloud portal to move the instances over to the new cluster. We can do that gradually. I would say we can do it in one big bang, but we would never do that. We do it some kind of canary. And again, the cloud portal allows us to move those instances to that new cluster and then tear down the old cluster. It's also responsible for the billing system events, and these are sometimes these are things you don't really think about when you build the cloud platform. We've got self-service in Octopus, so people can go on, spin a trial. When that trial ends, the billing system knows, but we needed something, a cloud portal, to react to those billing system events, to tear down either. I think what happens is when a trial ends, it moves it into the cold storage, and 100 days later, the cloud portal then deletes it. Okay, so the billing system, I can't remember what the billing system is called, but that will kind of send out a notification, and the cloud portal that we've wrote will pick up those notifications and run those tasks. Okay. This brings me to our kind of final lesson. I just talked about kind of build your own tools. It's much better, but use third-party tooling. Both free and possible wherever possible. One of the commercial tools that we know we were going to use is Octopus Deploy. Octopus Deploy gives us a single deployment process to deploy to thousands of these tenants at scale. And I promise you that's not a sales pitch, it's just one slide, I promise. But that's what we'd use for deployment. And then we'd also use a series of other tools. We have Sumo Logic, Seek, Grafana, Better Uptime, PagerDuty, and Snowflake. But again, most of these we are kind of bringing into our cloud portal. And I suppose while I'm talking, it's kind of come to my head. I've been talking about platform engineering and IDPs. And IDPs can be very similar to our cloud portal, pulling all the resources from these third-party tools or homegrown tools into one place. And that kind of wraps me up. So I've got a quick summary of the lesson. So I kind of said, cost shouldn't be the sole deciding factor when moving to Kubernetes. Brownfield migrations will have post-migration issues and expect them to take a lot longer than you originally planned for. Kubernetes and containers do not make sense for all use cases. I want to add that to that as well. Sometimes if you think, okay, I need to containerize this from a virtual machine, do you? Do you need to manage a full Kubernetes cluster to do a couple of apps? Not really. Take advantage of one of the cloud services. Use Azure Web Apps, use a Lambda function instead. I think it's what to add that on there as well. People get caught up in, you've got to be running this in Kubernetes. Well, actually, how much is it going to cost me to run this in Kubernetes just for a couple of apps? Just use one of the cloud services like Azure Web Apps to handle that for you. Okay. Now it's a cool thing to do to be running in Kubernetes, but sometimes it isn't. So not all managed services are the same. I talked about kind of the difference in the database between AWS and Azure. And then to run these kind of things at scale, you need a full-time team to manage these clusters and this cloud offering. And custom tooling might be required to help with that management, but use third-party tooling wherever possible. Okay, and that's me. Thank you.